We're going to graph. So this is called a rational function. So we're going to graph this. So first thing we need is the vertical asymptote, this weird ass word. So I'm going to take the bottom and I'm going to set it equal to 0. These are the steps that you're going to do on your exam. And I have to see each step just like this. So I'm going to subtract 2. I mean, this is pretty moronic, but we got to do it anyway. So this is a vertical line up and down through x equal -2. In hindsight, I should have drew my grid first. So 1, I'll make a couple tick marks. I'm going to have a vertical line. I don't know how well it's going to look, but I'll try. So this is the asymptote. You can never plug this number into this function because it makes the bottom into 0. So this is a freak. This is not in my domain. So this is how I tell people looking at the picture, you can't use this, dude. I can never cross that. If you cross this, it means that you were able to plug -2 in and get a value, but you don't. Now I need the horizontal asymptote. So this one's a little different. Here I have to compare the highest power of x on top to the highest power of x on the bottom. But they're both x. So basically you just have x over x. You take the numbers in front, which are 1s, and you get a 1. This is very important. This is y equals 1. This is x equal -2. The horizontal asymptote are y values. As the graph goes on either end toward -infinity and +infinity, the y values get close to this number. No matter what you plug in for x, if I plug in x as 100 or 1,000 or 10,000 or 10 million or 10 billion, no matter what I plug in for x, my value is going to be 1. It's going to be like 0.99999. So I have to come over to 1, and I'm going to draw a dashed line going left and right. Now you're almost there. I have to figure out what the graph does to the left of -2, right? There's -2. I don't know what to write it where it's going to look right. I need to know what the graph does out here. Is it up there or is it down there? And on the other side, is it up there or is it down there? And the way I'm going to do that is I'm going to plot 2 points. Now, you could say, oh, awesome. I'm going to pick x equal -5 and plug it in. If you just randomly pick some number out here to plug in and find the point, if I put -5 into the top and the bottom, -5 plus 2 is -3. I'm not plotting that. I mean, you want to get a nice whole number. So what I told you to do in the class notes was take the vertical asymptote, which is -2, and I want you to add 1 to that. So -2 plus 1 is -1. -1 is right here, right? There's -1, and here's -3. So I want to plug -1 into my function. So that's what I'm going to do. Everywhere I see x in my original function, we did this a million times in the beginning. We were plugging numbers in. This is really easy to do. Now, -1 plus 1 is 0 on top. On the bottom, I have 2 minus 1, which is 1. So 0 over 1, I hope you know, is 0. So you get the point -1 comma 0. Hopefully we can see. Hey, you can see the bottom of the board. Okay. So that's our first point. So I'm actually going to draw that. I have -1, 0 is right there. I need to plot that point. I'm going to erase that. And I'm going to erase that. All right, so that's my point. That's the first point. Now I told you, take the vertical asymptote and subtract 1 from that number. Real easy. Whatever you get, whatever number you get here, you add 1 and you subtract 1. -2 take away 1 is -3. Now I'm going to plug that into the original function. So you get y equals, right, -3 plus 1. And then you get -3 plus 2. Now again, why did I do this? -3 plus 1 is -2 on top. Now what's on the bottom? -3 plus 2 is -1. Negative over negative is positive. So this comes out to be 2. So you get the point -3 comma 2. See, nice whole number. How, let's say you got 3 over 7 there. How the hell are you supposed to graph 3 over 7? Or, 5 over -3? You can't graph these. I made sure that I picked an x value that gives me the bottom either being a 1 or a -1, so I don't get fractions to plot. Now I got to plot this point. So -3 is here, and then I'm going to go up 2. So it's about there. Now, this is the whole game. How the hell are you supposed to draw this? The dashed lines are like a magnet. I want you to try to draw a curve. So start trying to get close to that. Don't touch it. Don't cross it. Same thing here. Start trying to get really, really, really close. And, you know, this one you can cross. This is not a domain thing. The graph sometimes actually does cross it, but don't try to do that. So again, try to go close, 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 close. And then same thing here, go close, 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 but don't cross. What I don't want you to do, I like to call this the boomerang. I see students do this. They go like this. This is not happening. The graph does not do the boomerang, okay? The graph gets pulled toward the dashed line. It doesn't go away from the dashed line. So you have to make sure that it goes close, but it doesn't touch, all right? So I did my best to make them arcs. Some of you will make your graphs much prettier than me, but this is the general idea. Vertical asymptote, horizontal asymptote. Get 2 points to plot. Take whatever number it is for the vertical, add 1, subtract 1, and then plot those points after you plug in, find the y values. And then just draw little curves that go near the dashed lines. So, second example that I'm going to work. This one has an x squared on the bottom, but I'm going to run through the exact same steps I did before. First, I'm going to find my vertical asymptote. I'm going to take the bottom and set it equal to 0. Now, you know, if this was x squared minus 1, you would get 2 vertical asymptotes. Those are much harder and more complex to graph. This one, when you take the square root of both sides, you just get x equals 0. Easy peasy. Now, the horizontal asymptote, you compare the highest power of x on top to the power of x on the bottom. There is no x on top. There's x to the 0. So there's nothing to compare. The bottom has a higher power. So when you see that the bottom has a higher power, it's immediately y equals 0. Now I'm going to draw both of these. I'll try to draw this one a little bigger. So look, x equals 0 and y equals 0. You know, this vertical line is the y-axis, and this horizontal line is the x-axis. So, you know, the only way you could do that, I mean, you could draw them dashed. I just put a dashed line super, super close to 0, there and there. I don't want to draw my x-axis as a dashed line. It just looks stupid. Okay, so this is as good as I could do. All right, now I need 2 points to plot. Now, what I told you was take the vertical asymptote and add 1, and take the vertical asymptote and subtract 1, and then plug these numbers into the function. Well, this is kind of pointless, right? So I'm going to plug in 1 for x. So you get 3 over 1, which is 3. So I have the point 1 comma 3. Now I'm going to plug in x is -1. And guess what you get? The same damn thing. -1 squared is 1. So you get -1 comma 3. So I'm going to plot the point 1, 3 and -1, 3. So I'm going to come over here, make a couple of marks, 1, 2, 3. So I get -1, 3, and then I get 1, 3. Now I'm going to make arc toward the dashed lines as best I can. All right, I'm not perfect. Mine don't always look so good. And then again, an arc. The dashed lines are like a magnet. They pull the graph closer toward it. You can cross this one. You can't cross this one. The vertical one you could never touch and you could never cross. Okay?